Hey guys, what's going on? So today we are going to be talking about the Palatini self-duality. So we're going to be taking a look at the action we've been dealing with, which is the Palatini action. We've seen how it's related to GR, how namely it gives rise to Einstein's field equations, which is, that's all of GR in a nutshell really, Einstein's field equations. But we're going to specifically look today at self-duality, what self-duality is briefly, and we're going to implicate it into the Palatini action, and in that way we're going to get closer to an action that resembles something akin to a quantum mechanical formalism for this action. So let's go ahead and get started. Before we do that, make sure to hit that like and subscribe button. Make sure to go into my Patreon page if you want to support the channel. And also, if you want to become a member, you can feel free to do that as well. So let's go ahead and get started. Alright, so today we're looking at the self-duality of the Palatini action. Okay, so recall, so we're going to rewrite our Palatini action, right? We're going to keep everything there, but we're going to start to massage it in a way in which it's going to look. We want it eventually to look something like this, where I'll reduce the thickness of my pen, where we have QP, actually PQ dot, I believe it's PQ dot minus H, right? So this is what we want inside the integrand, something to look like that. And when we do that, we're going to see what P and Q are. Those are going to be our canonical variables for our quantum theory of gravity. And we're going to talk about this self-duality also, because I realize now that self-duality is something that I've sort of just kind of defined, and we haven't really talked about it in depth. We're going to talk about it a little bit in this video. So let's keep on going here. So the aim is to get a self-dual action, self-duality. We're going to cover this in a bit, but we're just going to recall a few things, and in doing so, we're going to eliminate the coupling between the total derivative at the end of this action. This comes at the cost, however, of defining a new variable. So let's recall what we've done so far and where we're going to go with this. So this was really our ADM formalism, right? So this was our ADM formalism. Here we were defining our triads, right? Triads. This is our densitized triad. And then densitized triad connection. Right, so all of these things we defined. So this, along with our Palatini action, gave us something that looked like that. And so with n, recall, or n being n over the square root of q. And so we ended up here, right? So, and this is quite interesting, right? Because we have our connection, we have this densitized triad connection, densitized triads squared, and we had all this stuff in here. So what's gonna happen is that we're gonna get to this point here. This is a constant. We'll take a look at that later. But notice here, this is quite interesting because we have a dot, right? So a dot, that's going to be our q dot, right? Let's undo that. This here is going to be our canonical momentum. Namely, so these two things, namely, are going to be our canonical variables. Just if we go broad, these things are going to be our canonical variables. So here's a canonical variable, here's another one, here's another one, and here's the other one. So you notice we have e tildes right? This tilde almost in every.
Hey guys, what's going on? If you're interested in this video and want to learn more about loop quantum gravity, string theory, and so forth, what you can do is you can become a member of this channel and you can gain access to all the videos that become uploaded on this topic and future topics as well. Again, thank you so much for your support and thank you so much for watching. This channel keeps on growing and growing, and I'm very excited to see where this is going to go in the future. So with that being said, make sure to hit that like and subscribe button if you like this kind of content. Make sure to become a member as well. Thank you, and bye.